We have a new project. Ay, ano na naman bagayaan? Let us connect to 5-volt supply. Power bank. This is our new project. This is a breathing LED circuit using one transistor and discrete components. Paano gumana yan? We connected the oscilloscope across our output LED red. Then we're going to supply the voltage 5 volts. So you can see here this is the waveform generated by the circuit. This is an oscillator. It looks like a clipper circuit with on and off, so that is the reason why LED turns gradual turning of the LED, slowly turning on and then off. On, it is on into the negative voltage. That is the characteristic, and with an offset voltage, because this is our reference voltage, we have an offset voltage. And then this truncated waveform is an off, and then the on is the negative voltage, gradually slowly turning on, then off, on, off, on, off. Now we have the schematic diagram of the breathing LED using one transistor. One transistor with many discrete components. So in our circuit we have one transistor. This is the output. We connected the oscilloscope here. The positive to the positive, negative to the negative oscilloscope. And we're having this output. So in our circuit we have this power LED turns on whenever we powering on the circuit with 5 volts, and then the current flows into the 1 mega ohm resistor, then to the capacitor 47 microfarad, and then to the 3.9K, then to the ground charging this capacitor. Also current flows from here and then to the C3 and then to the R5 to the ground, 4.7K charging this capacitor. Since capacitor is charging, it will bypass the base, so there is no base current into the transistor. That's why it is open, and therefore current flows into the output side of the transistor, R2 1K 3.9K, bypassing this diode, and then to the collector. And what happened to the collector to emitter? It will not flow into the collector to emitter to the ground because there's no base current of the transistor. So the current flows from 3.9K to the capacitor charging this capacitor, then to the R5 4.7K, then to the ground. All capacitor is charging at the initial state of the circuit. That's why we have this output. it is off. LED turns off. So when the capacitor is with the capacitor already charged, it will now discharge through the base of the transistor. Since there is an current to the base of the transistor, and then also current flows from 1 mega ohm to the base of the transistor, and then this capacitor will also discharge through the base of the transistor. It will now turn on the output side of the transistor, causing to turn on this LED. There is now the LED now turns on, and then current flows from collector to emitter and then to the ground. And this capacitor will also discharge through the collector. So they are all discharging. That's why we have this output waveform. Why is it that it looks like an analog or half wave or 180 degrees analog signal? Because of the RC network, and it continues and it is oscillating continuously. So it is an oscillator because of RC network, the two RC network into the input. As we can see here, we have the feedback to the output, input to the output. That's why it oscillates, and the oscillation is caused by the internal noise of the circuit. As we all know, or as we have known, internal noise is an analog signal. So they amplify, it amplifies the analog, but only the half of it, half of the analog, the internal noise from the circuit. It continues oscillation is present in the circuit, and because of the internal noise, it generate this analog type waveform. So that is the process of oscillation. The charging with no output, and then discharging, it will turn on the LED at the negative voltage. Since we're using the output of the transistor in the collector region, charging and discharging of capacitor, that is the cause of this. That's why we have this waveform.
Waiting